and I'd like to welcome Nick Dunhill to our session for today at the virtual show. Welcome, Nick.
James, welcome everybody, and welcome to the show. And thanks for getting up so early in the morning to come and watch us make valve gear. For those of you that don't know, I've been doing a number of presentations for the Guild about scratch building locomotives. And we've been building this Hull and Barnsley railway loco now for, I don't know, the last couple of years or something, in various sort of sessions that have appeared on the Guild YouTube channel and in virtual shows and even at some of the live shows as well. Because the loco's nearly finished and the guy who's having it was starting to feel a bit guilty, we decided that we would turn it into a charity build. And when the guy eventually gets the model, he's going to make a pretty hefty donation to his nominated charity, which is called WaterAid, which are a organisation that provides sanitation and fresh water to people in the developing world, which I think is a very good cause. And if you go, when you eventually leave this presentation, you'll see that there's a link to the charity. And if you could make a small donation there, we'd be very grateful. Thank you very much. As James says, if you really, all I'm going to do today is just to describe how I made the valve gear. Obviously, it takes me a couple of days to make a set of Stevenson link motion, so it's not really practical for me to sit here and show you how I do it end to end. So as you'll see in a minute, I've already made it, but I've disassembled it, and we'll go through some detail about how I did actually make it in the first place. And if at any point you want me to stop and clarify something, then either, we'll let James decide whether you can get in touch with me through the chat function at the bottom of the screen, or whether you could just unmute yourself and shout out.
I think in answer to that question, Nick, given the number of people we've got here at the moment, if you do want to ask a question, by all means, unmute yourself and ask Nick directly.
Yeah, we can do that. That's no problem at all. Right, let me switch you over then so that you're on my webcam that's here above me head so that you can see what I'm up to. Right, you can all see me now, can't you? Has that flooded everything out a little bit? It has, hasn't it? There we go. Right, well, here's the chassis. And it's got half a set of Stevenson link motion already installed in it. And these are just castings that are commercially available through Laurie Griffin. I think most people that are installing Stevenson link motion probably use Laurie's castings. They've been on the market now for years and years and years and years, and I must have made dozens and dozens and dozens of sets of them. I suppose before I start, what I should mention is the crank axle. There is a separate YouTube video that went live when the show opened about 25 minutes ago that shows in a little bit more detail how I assembled the the crank axle. The video's there live now, so you could go and watch that when you've watched this presentation. And I won't waste too much time describing how I made the crank axle. But the crank axle is one of the things that you have to bear in mind when you're building the chassis. I think it's very difficult to fit inside motion into a chassis that's already been built. It's very difficult to fit it retrospectively. I found in the past that you just end up having to rebuild the chassis, really. Some manufacturers, when they put a kit out on the market, do put these stays here, in the correct place, where they would be prototypically. But other kit manufacturers don't. They just put random stays in the chassis, and you'll need, before, if you are planning to put inside motion in your chassis, you will have to think where you put the stays. And obviously the best the best starting point is to put the stays where they need to be, where they would have been prototypically, and start from there. Now I had the opportunity to do that with this chassis because we built it from scratch, and I kind of had in mind that the guy might want inside motion fitting, because the loco is kind of one of those locos where there's a really big area here underneath the boiler that's just crying out to be filled up with inside motion. So we did that. Now, most locos all locos basically are very similar. They have a stay here, and if you can imagine, this is where the firebox of the loco would be, and there would obviously be an ash pan here in this area, and there's always a stay in front of that. So we've put a stay there. And then you always have a motion bracket, because obviously that supports the rear of the slide bars and often the valve rods, although sometimes the motion goes through on very old Great Western locos, for instance, and broad gauge locos, the eccentric rods actually go through the motion bracket and the expansion links are here. But fashion later seemed to be to put the expansion links behind the motion bracket. But anyway, you need to think about that. And when you put in this motion bracket in place, you have to cut it for all of the, can you see that? You need to make holes in it to support the ends of the slide bars. And quite simply, you measure the end there of the slide bars and make an appropriate hole there, one at the other side. And some hole, you can see also that I've made some holes here for the valve rods as well. There are some castings to support the valve rods, which we'll come to in a minute. So you also then need to make a cylinder rear, and it's also a good idea to make holes in the cylinder rear where the piston rods and the valve rods go through. So that's kind of a good place to start, because your cylinder centers really are going to be dictated by your crank axle. I mean, obviously you can go and get a drawing and you can pick the dimensions off the drawing and use those. But often in fine scale, you can't, because the chassis is significantly narrower than it would be prototypically. So that does mean sometimes that your crank axle ends up having to be compromised a little bit. Quite often you maybe find that you have to put your crank castings in a lathe and skim something off one of the crank webs, or maybe even shorten the make the wheel bearings and the horn guides a little bit narrower than they would be prototypically, just so there's enough room to get both crank webs and all the eccentric sheaves in between the axle boxes. So often in fine scale, there's just not enough room. But anyway, what you'll find in the Laurie Griffin kits is that there are sets of cast eccentrics. They used to be machined, but these days he does castings for them. Now, in my experience, the eccentric straps, which are these circular bits here on the other castings, they're actually too small. You can't get his cast eccentrics inside them. And for a while, I used to sit there endlessly with files, trying to file bits off eccentric sheaves to make them fit inside the eccentric straps. And in the end, I gave up, and I got somebody to make me one of the guild guys who has an engineering shop of his own, set up one of his CNC machines to make me a load of eccentrics out of steel. And I have to confess that they're all quite a sloppy fit inside the eccentric straps. And I think, well, certainly that helps me, because obviously I build commercially, and I can't be spending days and days and days on end trying to perfectly line up eccentric sheaves with the eccentric straps, so that they're not binding. It's much easier from my point of view to make the eccentric sheaves quite undersized. And when I say quite undersized, it's something like 0.5 millimeter less in diameter than the finished diameter of the straps. that means that almost immediately the eccentrics will turn inside the straps without binding, and then I don't have to spend days on end chasing a bind somewhere, some kind of tight spot that obviously compromises the running of the loco. And that's kind of a theme all the way through this build as well. For instance, when I'm filing the big ends in the connecting rods, I always make those a fairly sloppy fit over the big end casting on the on the crank webs just there. Obviously, to not be a good idea once you've cut through the axles to start filing down the big end journals here on your crank webs. It's much easier to open up the big end eye in the connecting rod. So you open them up so they're a little bit sloppy, but there's still enough movement in them, so that the crossheads move very nicely down the slide bars, and that the same in the eccentric straps. They're quite a sloppy fit on the eccentrics, but there's still enough movement to move the valve rod to and forth, which is what you want to see when the motion's running. So anyway, guys, that's my main secret. I've given away my main secret of how I make inside valve gear. And I'd recommend you do that. Get yourself some eccentrics made, or if you can't get some, just get in touch with me and I'll let you have some of mine. I've got dozens and dozens and dozens and dozens and dozens that what's his name, Dobson machined for me, and I'll never get through them all. So if you want them, they're here. Right. So the next bit, after we've decided where the stays are, really you need to have a drawing. I mean, all I had was this drawing here. But you can see here on the drawing where this is the motion bracket here. So you know where that fits. And the end of the firebox is here. So you know there's going to be a stay just in front of that. And it's a fair assumption that the front of the cylinder block will be in line with the rear of the smoke box. That's usually the case, and that's the assumption that I worked on. So that's kind of the first step, really, is making the frame stays, putting the frame stays in your chassis in the correct place. And the last consideration is making sure that the holes in your cylinder block and the holes in your motion bracket will capture your slide bars in a way that makes the slide bars parallel with the center of the driving wheel. If I get a piece of paper and try and articulate that a little bit better. So if this is the cylinder, and this is your motion bracket, and your slide bars need to be captured so they're at 90 degrees to your cylinder front.
Those lines aren't coming out very well. Oh, that's better. There's too much light on.
Is that better?
That's better, yeah.
So this is the front, this is the rear of the cylinder, and these are the slide bars, and they're obviously always perpendicular to your cylinder block. And this is your motion bracket that supports the ends of the slide bars, and this is going to be the center line of the cylinder. It'll obviously be centered down the slide bars, and eventually that has to hit the center of the axle. That's kind of a basic principle for setting up any kind of valve gear, even Walsh-Chart's valve gear on an outside cylinder locomotive. The cylinder centers always point at the axle center. So that's something that's worth bearing in mind when you're building any kind of motion for a locomotive. Now, I was very lucky because in this case, the cylinders, because the locos are got a 240 wheel arrangement, it's got a small wheel at the front, and the axle doesn't interfere at all with the slide bars. The axle lies here, just underneath the slide bars. So in this loco, the cylinders are mounted horizontally. Now, obviously, sometimes you'll find on some locos the cylinders are up here to avoid a driving axle that's underneath them. But the principle still remains the same, that the cylinder centre has to point at the wheel centre. So once you've got the basic geometry of your chassis set out, and I think that's really important, to pay a lot of attention to that while you're building the chassis. And it will mean, if you're building it in a kit, that you probably have to move away from the design of the kit. And you may have to experiment a little bit with the motion bracket as well to get the hole for the slide bars in the right place. And also you have to remember when you're making the hole you need to make a hole there like that, for instance, in the motion plate for the slide bars, and the slide bars will sit here in the corners like that. It's also a good idea to scallop this bit out as well, as they would have been on the real thing, because the conrod might end up passing into this area when it's at mid-stroke. And also you might be worth taking a bit of material out here, because you may find that your crossheads might crash into this otherwise. So that's kind of a good practice. And I think also when you're making a motion bracket, you need then to, when you've cut these holes here for the slide bars, you need to take into consideration where the valve rods are going to go through the motion bracket. And if we move back to the the chassis I've got here, you'll see that, I mean, this is a really, really typical Lorry Griffin setup, where the kit has these castings in it here that support the valve rods. And obviously they need to be, on the same axis as well. And you need to fettle them, and you need to bore them out as well, and make an appropriate hole in the motion bracket to support this casting, and then also a hole in the cylinder rear to support this casting, and then make sure that your valve rod here, look, this is the valve rod that I haven't put in it yet, make sure this is fettled really nicely, and a really nice sliding fit in your valve guides, again, so that there's no binding. And also what you'll find is that this, because the whole cylinder centers are probably narrowed a little bit in fine scale, you'll probably find that this casting comes into conflict with the cylinder rear castings here, into which the piston gland lets itself, and the slide bars. So you might find yourself having to cut a bit away, which I have had to do here. Look, if you can, I don't know whether you can see that. I've actually had to chop bits of the cylinder covers away and the valve guides, to make them fit into the space. So that's something you may have to do as well. So once you've got your...
Nick, just a quick one.
Yeah, go on.
You're talking about castings for the cylinder, the ends of the cylinders, and also the piston rods.
Yeah.
Do they all come as separate pieces?
Well, the in Lorry's kits, you get the slide bars come as one casting. This is a typical sort of 4-bar slide bar setup that you get in loads and loads and loads of these locos that have got Stevenson link motion.
Yeah.
And the piston gland is cast into the end of it, and that fits into a circular cylinder head casting, a cylinder head cover casting, which is there. So that hole you have to bore out to fit the end of the slide bar.
Yeah.
And similarly, you'll see on the back of the valve rod castings, there's a kind of an oval shaped hole that you have to recreate in the cylinder rear section that you make. I mean, it sounds very technical, but it's not really. And if you're lucky, these stays are in the right. Like, for instance, in Dave Andrews' kits, he always puts the stays where they would be on the real chassis. And often he kind of pre-makes the holes for you. He'll etch a little hole where the cylinder centers should be, to help you out. So really, all you have to do is open those out. I suppose the next bit, really, when we've dealt with the stays and the centers and things, we've looked at the crank axle. That's on a video. the next bit really is fettling all the parts for them. Now then, I don't really want to criticise Laurie for this because he is a bit of stalwart, and I'm so grateful, for all the help he's given me over the years and that he supports the hobby. But I wish he'd go and get his wax molds remade at Slater's, because they've been thrown so many times that some of the castings you get off him these days are a bit, they're suffering a bit from the molds wearing out, I'm guessing. And bless him, Laurie, he donated these rods because he knew we were doing a charity build. As did one or two other people that sorry about this, but I'm going to have to mention because they have contributed, giving us parts either at cost or free for this build. And it's people like Laurie Griffin and Diane Carney. Model Yard in Leeds have donated a decoder at cost. I've got Mick Davis, who's done me loads of 3D prints, and then Mike Hopkins at Scale Factor, who's made me some absolutely amazing castings for the backhead, which we'll come to in a future presentation, I think in February or maybe in July. I'm not sure which. But anyway, the thing about Laurie Griffin's castings is you just have to sit with a coffee and the Archers or your favourite podcast on and just file and file and file and file. And there's no secret to it, really. You just have to file the slide bars and the crossheads and all the parts until they're smooth. And it does take some time. And especially with the slide bar castings, you do have to spend a bit of time straightening them up as best you can and making sure that they're all parallel with each other and they're not twisted, because they do tend to twist a little bit as well sometimes, and you need to kind of find a way of untwisting them without breaking them. But really, it's just hours and hours and hours with files and emery paper and wet and dry and so on. And also, you've probably seen dozens and dozens of times when I've done these presentations that I do like to use a sanding disc in a mini drill. It is just a rubber arbor, and I do cut out circles of wet and dry paper with double-sided tape on the back. And these really do help to just rough the castings, before you actually start filing them. You can quite quickly, kind of take all the rougher bits off with a sanding disc. I highly recommend it. Saves me hours and hours and hours and hours of work. And with some of these castings as well, you'll find that they've got pinholes in them. So you're probably going to have to fill the holes with solder as well and then go back and do even more filing. But the rods, they do come up quite nicely. So what I would do is rough them out with this and then stand them on a wooden block, and just file and then start draw filing as well, where you use the file sideways in that sort of motion, and then wrap some wet or dry paper around your file and do it again, and then reduce the coarseness of your wet or dry or emery or whatever your favorite abrasive is, and sooner or later you end up with really nice finished rods. And it just takes forever, but you just have to put the hours in. And then of course the next thing is to make sure that the crossheads fit quite nicely into the slide bars. And again, I can't emphasize that if you've got any tight spots, it will manifest itself when you start trying to run the loco. So you need to make them a very easy fit in the slide bars before you start trying to fit everything up into the loco. And also make sure that the small end joint here is really smooth. And if you're an engineer, shut your ears at this bit, but it might also be a good idea to make the small end bearing there a little tiny bit sloppy, so the conrod can sort of move a little bit from side to side, just in case your big end journal isn't completely circular, just to stop any binding. No, it's not very good engineering practice at all. But you have to remember, no power at all is going through these rods. They're just being pulled along as a passenger by the electric motor. So, they're not going to wear out if you introduce a little bit of slop into your joints. As I mentioned a minute ago, that's what I do with my eccentrics and the eccentric straps. There is a fair amount of slop in them. Enough to get some movement in your valve rod, but not too much so they bind partway through their rotation. So when you've done that, obviously, then you can fit slide bars into your chassis. I mean, these go in from the top like that, and they just slide like so into the holes that I've made in the motion bracket. They might need a little bit of encouragement. There we go. And then you can pop that there into the cylinder front, and that is that piece installed. And before I go any further, then I'll turn to these eccentric rods here. Now, on lorries sets, they come in two parts. You get this kind of forked joint here and a run of rod to about there. And then you get another casting for the half of the eccentric strap. And then you get a third casting, which is that piece, which is the kind of continuation of the eccentric strap. And this is a good thing because these clip together quite firmly. And it means that you don't have to have these in place when you're soldering up your crank axle. In the old days, this came as one casting, and you had to, when you were soldering up your crank axle, you had to have your eccentric rods on your eccentrics. And obviously, you were always in danger then of soldering the whole lot up. But anyway, that was a... But, a lot of people have been in touch and said, well, how on earth do you make these rods? Because it's not very easy to make this joint here in the middle of the rod. And obviously, this isn't the definitive way of doing it, but this is how I do it. You kind of have one casting that's the forked end like so. And basically, all I do is I file a step in it, just there in the rod. That's where your pin goes through. And then this part of the eccentric strap has a corresponding piece that goes in there that I file an opposite, if you like, piece out of. And there's the top of the eccentric strap there, and there's the other bit of the eccentric strap. So what I do is I file a rebate out and then a matching rebate in the other rod, and they don't have to be perfect. So long as when you put that face and that face together, this coincides with this and this coincides with this. That is very helpful. And I made this years ago, and this is a jig. Don't know whether you can see that as the camera rotated that, but it says Laurie Griffin's eccentric rod jig. It's just some bits of brass and wood that I screwed to a bit of firewood, essentially. But what they do is they hold the rod there, like so, and then you can look at your drawing and find out what the centres of the eccentric rod are. In this case, look, it's 3.15 millimeters because I've drilled a hole there on the axis. I've drawn an axis there. I don't know whether you can see that. The centre line of the rod that's perpendicular to this bit of wood here that's the kind of end stop. And I've drilled a hole where the centres of the rods should be. And then what I did do is stick a 0.8 millimeter drill into that hole and drop the forked end here over the 0.8 millimeter drill. Obviously, I've drilled these holes out here in the forked joint to 0.8 millimeters. And then, so the drill will hold this part of the rod, and the jig here will hold this part of the rod. and then you just flood the joint with solder. And I always use electrical solder as well because it's got a slightly higher melting point and it's slightly more resilient when you come to tweak them straight later. And then it's just a case of filing and filing and filing some more in exactly the same way as I described before, where you rough them out with your mini drill and then get in there with a file and then draw file them and then emery them. And it literally does takes longer to file up all of these rods than it does to fit them into the loco. But you just have to be patient and sit there and do it. And then, of course, the next stage is fettling the what do you call it? The expansion link. Sorry, this banana-shaped piece here, and you need to pin a rod to the top of it, and you need to pin another rod to the bottom of it. But you need to make the forked ends the opposite way round so that one rod will pass beside the other. So the straps are parallel to each other and parallel to the expansion link, but they pass next to each other so that they can be mounted on adjacent eccentrics on your crank axle. And it's really helpful to make these joints here not sloppy at all. If you can let the rod tilt, again, engineers, close your ears. If you can make it so that the eccentric straps here do rotate very slightly on the axis in that direction, if there is a little bit of slop there, you'll find that is beneficial because it'll kind of limit the number of opportunities the rod has to bind while it's rotating on the eccentrics. And over the years I've been doing this, I've discovered that although it's really not very good engineering practice, it is kind of a good way of making sure that your valve gear works first time without binding. So I would highly kind of recommend that you do that. There is as you can see, there is a little bit of tolerance both in that direction and in this direction on the rods. Just a tiny, tiny, tiny bit. And also it's a good idea when you put these pins, and I always solder the pins into the eccentrics, into the forked joints there. Just dab them ever so quickly with your soldering iron with some 145 solder, just a quick dab, just so you get a little bit of penetration, just enough to hold the pin in place, but not enough to solder the joint solid. It's just a technique that I've developed again down the years. It's a quick dab and then away. And then what you really need to do as well is to file the ends of these pins so they're flush with the fork joint here. So make sure that the pin is flush inside there so that there's no chance that when they pass each other, and they're going to pass quite close to each other on the motion, there's no chance that they crash into each other and jam it. So that's something else to look out for. And the last bit is making sure that the forked bit here on the end of your valve rod fits really nicely into the expansion link. The expansion links have got a cast slot in them. Now, often these cast slots are just full of, kind of bits of material that really shouldn't be there. And sometimes you can file them out, but a good way of roughing them out is to get a drill that's the diameter that you want this to be finished. So I'm guessing that I've put something like 0.4 maybe millimeter pins into this. No, I haven't. Look, I've gone smaller than 0.4. I bet you we're at 0.2. We are. If you get a 0.2 millimeter drill and shove it in the chuck of your mini drill, you can then push it into that slot. This is terrible engineering practice. This should be done, kids, on a mill with a slot drill. And you should set this up on your indexing table and go around it properly, But I don't. I just get a 0.2 millimeter drill, shove it in my mini drill, and go in there and try and use the drill as a grinder to get all the bits of crap that are out of there until you've got a nice sliding fit in there for a 0.2 millimeter pin, 1.2 millimeter pin, which is what I'm going to use to pin this in there. Also, you need to get a grinder and make sure that this fork joint really slides very nicely up and down your expansion link. I think that's really important as well. I mean, it's not going to move very much. And, well, maybe you will build a locomotive where you can turn the handle on the footplate of the reverser and it moves the lifting links up and down. Maybe you will do that, but it is important because the valve rod will move very slightly up and down in the expansion link. So you have to make sure that it doesn't bind on this little ear. See what I mean? There's a little ear there that the lifting link attaches to. Sometimes you have a lifting link on both sides as well, and you have to make sure that the valve rod passes through them really nicely and it doesn't bind, because obviously that's another opportunity for your valve gear to bind up if that's not the case. So then it's just a case then of fitting it all in. So we've put the slide bars in, and by now your valve rod should be a nice fit in there, and it is like so. You'll see that on some of these sets, and this is one of them, the centers of the valve guide there and the valve guide here are offset. So your valve rod will come out of the gland in the back of your cylinder like so. And the valve rod is then offset like that. And the forked connector to your expansion link is here, but it's slightly offset from the center of your valve chest here, and you need to make sure that you put the valve rod in the right way around. Now, these castings that Lorry makes do compensate for this. So you'll find that the valve rods are like that. They're both offset outwards, like so. And this casting that supports this bit, these ends of the rods, the rear ends of the rods, will compensate for the fact that the centers are different. So bear that in mind when you're lining everything up. Let's get rid of this bit of paper. Here we go. So the next job really is to fit everything into the chassis. Now, somewhere around here, I've got a load of pins that have all rolled off. And also there should be there it is, a little pin there, look, that holds the valve rod there into the expansion link there. So what I'm going to do is, what I should have mentioned as well, while I'm filing up the eccentric straps, I always file this hole. These things never, when the castings arrive, you'll find that they're never completely circular. So it's a good idea to get a big drill that's approximately the right diameter, and just to check it with the shank of the drill and tweak it as best you can to make it into as near as a circle as you can possibly get it. And file these edges as well so they're continuous, so that they don't give an opportunity for any jamming on the eccentrics. So you'll find you'll need to take a bit of material here and there, and off the faces as well, here and here, to make sure that they're nice and parallel to each other. Well, you won't get them perfectly parallel because the castings aren't good enough for that, but at least you shouldn't leave any edges that are likely to catch on the corresponding edge on this rod. Because again, it'll just give the rods an opportunity to jam up in use. And also what I do is, you can see that they fit into each other. You have to drill some little holes there, and the ends of the eccentric strap have some little pegs on them that fit into the holes. And again, this isn't very good engineering practice, but I kind of bend the pegs out slightly or in slightly, so that when you fit them into the holes here, they jam into the holes. You'll feel them kind of click into place, and they'll just hold each other as an interference fit. And that's, kind of quite a nice idea for when you're trying to just fit them up and test run them. Right, so let's try and put this in the chassis. I think we've got enough time, haven't we? 15 minutes should be enough time just to assemble the whole thing and just to prove to you it does work.
I was going to say that if anybody would like to ask some questions, we've got, as Nick says, we've got 15 minutes left of our session today. If you'd like to ask Nick any questions, then please go ahead while we've got time.
Fire away.
And please unmute if you'd like to and ask Nick, or we'll just watch him get on.
So I'm going to offer these into the chassis here.
I do have one question, Nick, and that's with all these components, do you mark them in any way to make sure that you assemble the right bits?
I do. So they all go back where they came from.
Right.
But if you watch, I've just laid these out. You see, I've laid out the bit of the eccentric strap that clips on. I've laid them out in the order that they've gone into the chassis, and they come with a little peen mark cast into them there, so that you know where to register them. Okay. I think it's always a good idea to put things where they came from. Similarly, the big end castings in two halves as well. And if you look, you probably won't be able to see them, but I have scored on the rod which side they are and which is the top. And obviously you can tell with this casting which the top is because it's got the oil pot on it.
That's right. Yeah.
And similarly, I've pushed these parallel parts in very slightly, so you kind of have to force them a little bit onto the end of the conrod.
Yeah.
So that they'll just, they'll just hold in that position while you're assembling everything.
Going back to you were saying that you joint the rods part way along. This is presumably because Laurie casts them extra long.
He does, so that you can cut them to the length that you need.
Yeah.
But you'll need a drawing. If you don't, actually, you can make a reasonable stab for how long you want your eccentric rods to be.
Yeah.
Just by looking at a drawing, because for instance, on this drawing, you can see where the motion bracket is, and you can see where the wheel center is. Now, of course, the eccentric centers are going to be in the same place as the wheel center. Well, they're going to rotate around it, aren't they? Yeah. But the center point of the rotation of the eccentric will be on the axle center. So if your motion bracket's here, you want kind of the centers of your eccentric rods maybe to be 2 or 3 millimeters behind that. Maybe the length of the fork joint plus a bit. So you can kind of work out from this quite basic drawing more or less how long the eccentric rods need to be. And as I said, in this case, they were 31.5. There are no measurements here, so I just went 31.5 millimeters, which puts the end of the eccentric rod somewhere around here.
Yeah.
And then, of course, just here you've got the die block for the shaft for the lifting links, and then you've got kind of the reach rod for the lifting links, and you kind of know that the ends of the eccentric rod need to coincide here with the end of the lifting link on the way shaft. So it is possible to make a kind of a educated guess about how long the rods need to be, even if you don't have a drawing of the valve gear. For instance, you know where the front of the cylinder block's going to be, and you know where your motion bracket's going to be, and the slide bars generally don't extend much beyond the ends of the motion bracket on Stevenson Link locos. And therefore, you know where the centers of your slide bars are going to be. And you have to discount the part of your slide bar where the piston gland is and measure from the end of the piston gland to wherever your slide bars finish, just beyond the end of the motion bracket, which, as I say, isn't far, no more than a millimetre. So you know where the middle is, you know where your axle centre is, so you know how long roughly your conrod needs to be. So that's where I started. I made the centres of the conrod that dimension, and then if the crossheads do crash into the cylinder block or pop out of the front of the slide bars, then you can move the little end on the conrod very slightly, to compensate for that. You can solder the hole up and move it a little bit, then, can't you? And you can get away with it like that. So it is possible to guess those things. Sorry, I fell down a rabbit hole there and didn't really answer your question, didn't I? But the answer to your question was yes.
Yes, okay.
Yes, I do put all the parts exactly where they came from. This is quite difficult because I'm trying to now pin the valve rod to the expansion link, and of course you can't see this happening because my webcam isn't. There you go. Put the pin in there. Go on, pin, get in. I'm going to a football match straight after this.
With the crank axle,
yeah.
Are you saying your crank axle wasn't from Lorry? It's something that you've had made?
No, it is from the. I bought his kit. He supplied me with the whole kit because he's such a kind man, and I only use the crank webs and big end castings out of the kit.
Okay.
I have my own eccentrics made by Thingy Dobson in his engineering shop. He made me a load of steel eccentric sheaves, because the cast ones that come in Lorry's kits are just a bit crap. They're too big as well for the eccentric rods, so they don't, the eye of the eccentric rod, the eccentric strap won't go over the cast eccentrics, which is just a bit of a non-runner, isn't it?
Yeah.
So rather than sit there for hours trying to make them fit with a file, I just chucked them away and got my own eccentrics made. If anybody wants them, they are available. You can have them. I've got piles of them. He had to make me 200 of them or something. It'll take me a whole career. I'll have retired before I get through them. So if anybody thinks they want some, just get in touch and I can sort you out with the eccentric straps. Sorry, eccentric sheaves. That's very straight.
Can you get cranks with different throws?
Now, I don't know. I'm going to assume that Lorry, yes, I know he does. But you're kind of stuck a little bit with the sizes that he does, and mainly the sizes of the crank throw, the crank web. It's kind of designed more for kind of bigger goods engines, that kind of thing, than it is for really small engines like this. But I looked out a bit with this loco. He did say to me that he had some crank castings that were the right shape. In terms of their profile, they're kind of that shape. The crank web's that shape with the big end here and the axle here. And the throw was approximately right for the slide bars as well, because the throw of the crosshead has to be within the motion bracket and the rear of the cylinder. And I can't remember how many millimeters it was, but he did have a crank that was did have around the right crank throw. But if you look, I have had to chop a little bit off the ends here of the crosshead. The crosshead's usually got a little boss here onto which the piston rod's cast, and I had to cut those off because there just wasn't enough space here, because if you look, the slide bars are actually quite short. So I did have to do my own sort of modification for that. And you might find you have to do that as well yourself. But they're not very difficult to modify.
Can I ask a question, Nick?
Yeah, of course you can. Shoot away.
you've gone so far with the basic parts, but you haven't shown us how you connect the way shaft. And do you fit the motion in forward gear, mid gear, or reverse?
Well, that's a good question. I made the way shaft. I'll start with the way shaft. These are just you get these sort of die blocks here, don't you, in Laurie Griffin's sets? And most locos have these die blocks sort of bolted onto the frames somewhere, or sometimes they're sometimes in between the frames, not sticking out over the top, and sometimes often they're at the bottom as well. So essentially, what I did was mount the die blocks, put a piece of brass rod through them, and then solder the way shafts. Well, actually, the way shafts aren't soldered onto the shaft to start with. You then have to assemble all the valve gear and move the lifting links into the right place, and then solder them in position. And the lifting links then connect to a pin there that goes through the lifting links like so. And then what I've got here is a piece of tube that goes in the middle of this pin like so. There's no way I'm going to show you how to do this because the presentation has to finish very shortly. So that basically you can see there's a bit of tube there in the middle of this brass rod. And you see there's a little gap there and a little gap there, and the lifting links fit here onto this gap. And this bit of tube spaces the lifting links in exactly the right place so that they drop down and support the expansion links in exactly the right place. So you've got your kind of expansion links there, and they've both got a lifting link attached to them on the outside there and there. And the lifting link comes vertically, and at the top, this piece of tube here spaces the lifting links so that they're in the right place. The other thing quickly that I haven't mentioned about Laurie Griffin inside motion is that you have, let me get another piece of paper. Here we go. You have your eccentrics here on your axle, and you have your expansion links here. This is a plan of the valve gear, and then there's the kind of lifting links here for the expansion links. And obviously you've fitted your rods so that one goes like that, and the one at the bottom is on the opposite side, like so. And these you'll find don't quite, the centers of these is never the same as the centers of the eccentrics. The eccentrics are always slightly wider than this dimension here of the 4 rods. So what you'll find you have to do, and I've always had to do this with Laurie Griffin inside motion, is the 2 inside rods will line up with the middle 2 eccentrics, but the outer ones you have to splay out slightly to meet them. And that's not very good, but all the sets I've ever made, you've had to do that, where you have to splay the outer rods out. And the other answer to your question is that I always mount them in not full forward, but a little bit forward gear, which I think's down, isn't it, on Stevenson Link Motion? Is that right, Ian?
Yeah. I think one of the problems is had to make compromises for the very narrow frames that you're using in
that's always like that. You always end up having to take a bit off. Well, you'll know this because you make dozens of these sets, I'm sure, as well. You always have to sometimes end up taking either a bit off the outer webs, put them in a faceplate on a lathe and just skim a bit off the end of the crank web, or take a bit off the axle box, thin the bearings down and the horn cheeks, so that there's enough space between them. Because you've got the frame here, haven't you, and the frame here, and then you've got your bearings here and the horn cheeks here, supporting them. And then there's not enough room then, is there, for all 4 eccentrics, plus your crank webs, and there's your big end journals, and you've cut your axle out, haven't you? Your axle goes all the way through. And there's just, like you say, there's just never enough room for everything in fine scale. But you don't do fine scale anyway, do you? You do scale
No, I've
7,
got
don't
an
you?
extra 2 millimeters.
Yeah, that's right. Yeah, and the extra 2 millimeters really does make a difference. It
Yeah.
really does. I find I always end up taking a bit off the bearing. It's easier just to skim a bit off the bearing and make the horn cheeks narrower. The
Yeah.
problem with putting these the problem with putting these big end castings on a lathe is that you realise how unsquare they are.
Mm.
There aren't two parallel surfaces, are there, that you can touch off? You know,
Yeah.
you'll put one on your surface plate on your chuck, and you clamp it to it, and then when you start spinning it, and you get a dial gauge and try to find somewhere on the outer crank web, and they're not parallel. They're often towed in or out when you get the raw castings, and of
Yeah.
course they've already been drilled, haven't they, to accept the 3/16 axle. So you can't really bend them out or in or whichever way they need to go, because then the hole's not concentric anymore. Although sometimes that can work to your favour. You can splay them back parallel, and then when you try to push the axle through, it becomes an interference fit, which kind of helps you sometimes, doesn't it? Because it locks the casting onto your axle and makes it easier to solder it, if you see what I mean.
Yeah, well, I must admit that I have stopped using Laurie Griffin's valve gear 'cause it's too much hassle. You're probably
Well,
quicker cutting bits from scratch.
no, I have done them like that, but if you're doing it commercially, you can quite easily lose a day, or two, can't you, doing that kind of thing? Cutting out there's a guy called Steve Ross who lives in Links, and he'll do that kind of thing for you, but he's got a pantograph machine, a sort of an engraving machine
Well, I
that's,
have, yes.
yeah, and I thought you might have, and so you've probably got a load of, cardboard or plastic patterns, haven't you, for cutting out all the various shape crank webs that you want, and it's
Yeah.
actually quite a straightforward job. But I have done it like that, but it's just time. It's just time. It's trying to hit a budget. Um, and sometimes it's just not practical. It's back to what James was saying earlier. Sometimes the crank throw. I made a P class loco for somebody last year, and they're tiny little 060 engines. Those sort of London and Brighton and South Coast P classes, tiny, tiny engines, and none of the castings in his kit were had a crank throw that was small enough. So I ended up having to make my own crank webs for them, just because the slide bars weren't long enough, otherwise.
Yeah.
And it did take forever, but it was quite a satisfying job, I have to say, at the end, when you've actually assembled the thing. And then, of course, the next problem was I found out that, of course, not only is the crank web casting, the crank throw, tiny, much smaller than normal, also the eccentrics are a much smaller diameter as well. And it was just outside the scope of the job, really, making eccentrics and then making eccentric straps to go around them. It would have taken me months to have done that, which is fine when you're doing it for fun, isn't it? But if you're doing it for money, not everybody's prepared to pay, are they, that kind of money?
One thing about the making it though, it's very satisfying to make it and have it work, but it
Yeah,
is
yeah,
very
yeah.
unsatisfactory not to be able to actually see it work because
Yeah, yeah.
motion is not visible when a locomotive passes you.
No,
Mm.
no, but on some locos like this, it really is, isn't it? You can see
Yeah.
right down there. You can see the valve chests between the slide bars between the frames, and it is quite satisfying. And
Yeah.
and I know it's not very good engineering practice, but I do always put a little bit of slot between the. I got these eccentrics specially made undersized, so the Laurie Griffin eccentric rods would be quite not a massively sloppy fit, but enough so that you don't have to keep taking them to bits and taking the crank axle out and filing more material off. I mean, you're fighting a losing battle anyway, because as they're supplied, these eccentric straps are never circular when you get them. They've probably been cast circular, but as the material's cooled, it's contracted and stuff. And when they've been packed and put in the post, the rods have always got bent a little bit, if they were ever straight in the first place. And I sometimes wonder whether getting etched ones made perhaps a better way forward, because making rods out of laminates of etchings is always a bit more of a reliable way of making sure that your rod comes out square and straight, isn't it? But it's horses for courses, really, isn't it? Because there's still a load of filing and dressing up involved in laminating etchers, so you're not going to win particularly, are you?
No.
Anyway, sorry everybody, I'm going to have to bring this session to a close.
Oh, can I just mention quickly that I am doing another presentation. If you want to see the next session of this build, I'm doing an evening with us sometime in mid-Feb, aren't I, James?
You are,
and
yes.
there we're gonna stiffen up the rear bit of the chassis here with an ash pan.
Yeah.
Thank you, Nick. Thank you, James.
Thank you very much.
So do pop along to that, and do consider making a small donation. Any shekels, anything, tiny amounts of money, just to help the charity along. That'd be really appreciated as well.
You'll find a link to the water charity on the website in the timetable. It's in Nick's session, so there's a link.
It's just above the link you click to get here.
Yeah, it's there available for you. Anyway, thank you very much indeed, Nick. The most informative talk. I really enjoyed listening to this.
Well, I hope it was helpful.
Indeed it is. And this session will be available recorded on the YouTube channel in a couple of days' time. In the meantime, I hope everybody enjoys the rest of the virtual show, and we look forward to seeing you at another one of our sessions. All right. Goodbye, everybody.
Thank you all. See you soon. I'm off to enjoy a bit of the show, then I'm going down the pub before the football match. Bye, everyone.
Bye-bye. Cheers.